Problem 8 of the MIT Integration B Qualifying Exam 2016, which is a definite integral from x equals to 50 to x equals to 100 of the floor function of log to the base 2 of x. This is actually a very interesting problem. Let's see how we may be able to solve it. This is our problem, right? From 50 to 100, we're integrating the floor function of log to the base 2 of x, right? The question is, what is the floor function? So what is the floor function? And what if, so if you have fx and we're getting a floor function of that fx, that is k. In other words, it's an integer value when fx lies between k plus 1 and k. So it's a discretization function that allows you to take the integer that is lower to the value of fx. If fx, for example, is at a given value of x is, for example, 2.5, then the floor function of fx at that point becomes 2. And if fx is 2.6 or 2.8, still that is 2. The moment it crosses to 3, then it starts becoming 3, up to 3.999, and then when it crosses to 4, then it becomes 4, right? So there are two methods for which we can solve this problem. I'll look at the short method, and that really just involves plotting the value of natural logarithm of natural logarithm to the base 2 of x. So this is log 2 of x, right? And it crosses 0 at value of 1. And we want to integrate from 50 to 100. So we see log 2x becomes 5 at 32 right? So log 2 of 32 is 5, right? And then it continues being 5, the floor function, in other words, until 64. That's when now it crosses to a value of 6. So this is 6. And it continues being 6. Now let me use dotted lines here. 6 all the way up to 100 and beyond. But these are our limits. So we want to find the area of, from here. So we want to find the area shown here. Let me use the blue demarcation. So see this box, and this being 5. This area. So from 50 to 64 we have about 14, right, units. From 64 to 100 we have about 36. It doesn't look like that. I mean, we didn't draw it to scale. And then the height here is 5. Yeah, and the height here is 6. So in other words, our integral from 50 to 100 of the floor function of log 2 of x, log to the base 2 of x, is equals to 14 times 5. That's the area of that rectangle, plus 36 times 6. which is here 70 plus this 6 times 6 is 36, carry 3, 6 times 3 is 18, plus 3 is 216. So this becomes 286, and that is the answer. Okay, so that's the quick and shortest answer method. For a much longer format, we can say method 2. So we say that from the integral from x equals to 50 to x equals to 100 of the float function of log to the base 2 of x can be looked at it in such a way that log to the base 2 of x, a float function, is equals to k in the interval log to the base 2 of x is greater or equal to k or less than k plus 1, such that 2 to the power k in between this region and k 2 to the power k plus 1 in that region, this value holds. So what we see here is our integral here tells us that we're going to have integral from 50 to 2 to the power 6. In that interval, we have 5 as our k plus integral from 2 to the power 6 to 100. In that interval, we have 6 integrated. So which is equal to 5x 50 6 plus 6x 2 to the 6 to 100, which is 5 times, this is 64 minus 50, 14 plus 6 times 36, which brings us to 286 as the value that we expected. Okay, so that's another way of simply looking at that problem. Pretty much the same. One is graphical, one is just purely analytical.